This is SpaceTime, Series 22, Episode 63. Coming up on SpaceTime, NASA chooses 4 potential sites for its OSIRIS-Rex asteroid sample return mission. Scientists expose one of the hidden secrets of the neutrino. And ASA, the Australian Space Agency, enters into a formal partnership with the European Space Agency ESA. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA has selected 4 potential sample sites for its OSIRIS-Rex mission to the asteroid Bennu. It's taken months for mission managers to find suitable sites on the mountain-sized space rock's rugged, boulder-strewn surface. Sample collection for return to Earth will be the highlight of the origin, spectral interpretation, resource identification, security regolith explorer, or OSIRIS-Rex mission. Since its arrival back in December 2018, the OSIRIS-Rex spacecraft has mapped the entire asteroid in order to identify the safest and most accessible spots for the probe to collect a sample. The 4 sites will now be studied in further detail in order to select the final 2 sites, a primary and a backup, in December. Mission managers had originally hoped to choose the final 2 sites by this time in the mission, but things didn't quite go to plan. You see, initial analysis, through Earth-based observations, suggested the asteroid's surface likely contained large ponds of fine-grained material. However, the first close-up images from the spacecraft instead revealed Bennu to have a surface covered with large, jagged boulders, making the task of even finding a safe place to touch down especially challenging. And yet somehow, among this brutal, sharp, rocky terrain, mission managers need to find an area containing sampleable material, fine-grained enough, that is less than 2.5 centimeters in diameter, for the spacecraft's sampling mechanism to ingest. 101955 Bennu is an Apollo group asteroid, meaning it's a neo- or near-Earth object with an orbit that intersects with and crosses Earth's orbit around the Sun. Bennu's a Type B carbonaceous asteroid, generally similar to Type C carbon asteroids, but with surface spectra suggesting anhydrous silicates, hydrated clay minerals, organic polymers, magnetite, and sulfides. But its most important quality is that this 492-metre-wide space rock currently has one of the highest known chances of actually hitting the Earth, with a 1 in 2700 chance of impacting the Earth between 2175 and 2199. Now, if it were to hit the Earth, the resulting impact would be the equivalent of a 1200 megaton thermonuclear device. The problem is, Bennu's orbit is intrinsically dynamically unstable. On average, an asteroid the size of Bennu can expect to crash into the Earth roughly once every 130,000 years. And dynamical studies have predicted a series of 8 potential Earth impacts by Bennu between 2169 and 2199, luckily none exceeding a 0.071% chance of impact. So, to help prepare for a worst-case scenario, OSIRIS-Rex is spending 3 years orbiting the asteroid at altitudes as low as 5 kilometers, mapping Bennu's surface and geology, studying its evolution, its composition, its chemistry, and its mineralogy. One of the key mission objectives will involve understanding non-gravitational influences, such as the Joukowsky effect. The Joukowsky effect involves sunlight heating up the surface of an asteroid, and that heat is then radiated back into space, providing a small amount of thrust as the asteroid rotates. Knowing Bennu's physical properties will therefore be crucial for scientists trying to determine the likelihood of this mountain-sized space rock slamming into the Earth. In July 2020, OSIRIS-Rex will fly down and hover just above Bennu's surface, extending a robotic arm to collect up to 2 kilograms of pristine asteroid regolith for sample return to Earth. The spacecraft's then slated to leave orbit in March 2021, with the sample return capsule being jettisoned for a parachute landing in the Utah deserts of the United States in September 2023. Luckily, the original mission schedule intentionally included more than 300 days of extra time during asteroid operations in order to address unexpected challenges such as finding a sample site. And 4 candidate sample sites were found, designated Nightingale, Kingfisher, Osprey, and Sandpiper. The 4 sites are diverse both in geographic location and in geological features. Nightingale is the northernmost site, situated at 56 degrees north latitude on Bennu. There are multiple possible sampling regions in this site, which is set in a small crater encompassed by a larger crater 140 metres in diameter. The site contains mostly fine-grained dark material, and it has the lowest surface temperature and lowest albedo, that is light reflectiveness, of any of the 4 sites. Kingfisher is also located in a small crater, this one near Bennu's equator at about 11 degrees north latitude. The crater is a diameter of about 8 meters and it's surrounded by huge boulders, although the site itself is free of any large rocks. Among the 4 sites, Kingfisher has the strongest spectral signature for hydrated minerals. Osprey is set in another small crater, 20 meters in diameter, which is also located in Bennu's equatorial region at 11 degrees north latitude. There are several possible sampling regions within this site. The diversity of rock types in the surrounding area suggests the regolith within Osprey may also be diverse. Osprey also has the strongest spectral signatures for carbon-rich material among the 4 sites. Finally, there's Sandpiper. It's located in Bennu's southern hemisphere at 47 degrees south latitude. The site's in a relatively flat area on the wall of a large crater 63 meters wide. Hydrated minerals are also present at this site, which indicates that Sandpiper may contain unmodified water-rich material. Later this year, during the mission's reconnaissance phase, OSIRIS-Rex will begin detailed analysis of the 4 candidate sites. During the first stage of this phase, the spacecraft will execute high passes over each of the 4 sites at altitudes of about 1.29 kilometers in order to confirm that they're safe and that they really do contain sampleable material. Close-up imaging will map the features and landmarks required for the spacecraft's autonomous navigation to the asteroid's surface. The team will then use the data from these passes to select what will be the final primary and backup sample collection sites in December. The second and third stages of the reconnaissance will then begin in early 2020, when the spacecraft will perform a series of passes over the final 2 sites at lower altitudes, taking even higher resolution observations of the surface in order to identify features such as groupings of rocks that will be used to navigate to the surface for sample collection. This is SpaceTime. I'm Stuart Gary. Scientists have finally determined the mass of the lightest known neutrino, finding the abundant ghost particle to be at least 10 million times less massive than the electron. The findings, reported in the journal Physical Review Letters, didn't offer a fixed number, but it did narrow it down, setting an upper limit for the mass of the lightest neutrino at 0.086 electron volts. However, the findings don't set a lower limit, with the study's authors admitting it's possible that they don't have any mass at all. Neutrinos are elementary subatomic particles generated through radioactive decay in stars, through supernovae when stars die, in nuclear explosions, in particle accelerators, and in atomic reactors. The neutrino is so named because it's electrically neutral and because its rest mass is so small it was originally thought to be 0. They're the most common form of matter in the universe, and having almost no mass means they're capable of being accelerated to almost the speed of light. Neutrinos come in 3 known types called flavors. There are electron neutrinos, muon neutrinos, tau neutrinos, each of which has its own specific and unique properties. Now, confusingly, these 3 flavors of neutrinos don't line up with the 3 mass species. It seems each of the flavors can be made up of a quantum mixture of the 3 mass species, so any particular tau neutrino, for example, would still have bits of all 3 mass species in it. And it's those different mass species which allow neutrinos to oscillate between the 3 flavors. So, for example, an electron neutrino produced in, say, a beta decay reaction may interact in a distant detector as a muon or tau neutrino. Although they have no electric charge, neutrinos do have their own corresponding antimatter counterparts, identified by their opposite chirality or handedness. The other interesting thing about neutrinos is that they only interact with matter through gravity and the weak nuclear force. In fact, they're so weakly interactive that several trillion are passing through you right now, without you even noticing them. Scientists believe it's important to better understand neutrinos and the processes through which they obtain their masses, as they could reveal secrets about astrophysics, including how the universe is held together, why it's expanding, and what dark matter is made of. The study's lead author, Dr. Arthur Loureiro from the University College London, says science knows very little about neutrinos, but it does note that they change between their 3 flavors, and this can only happen if at least 2 of their masses are non-zero. It seems the 3 flavors are always present, but in different ratios, and the changing ratio and the weird behavior of the particle can only be explained by neutrinos having a mass. The concept of neutrinos having mass is a relatively new one, with the discovery in 1998 earning a Nobel Prize in physics. Even so, the standard model of particle physics used by modern physicists has yet to be updated to assign specific firm mass numbers to neutrinos. The authors in our study used an innovative approach to calculate the masses of neutrinos by using data collected by both cosmologists and particle physicists. This included using data from the 1.1 million galaxies of the BOSS, or Baryon Oscillation Spectroscopic Survey, which is measuring the rate of expansion of the universe, and constraints from particle accelerator experiments. Rero and colleagues used information from a variety of sources, including space and ground-based telescopes observing the first light in the universe, the cosmic microwave background radiation. That's the leftover heat from the Big Bang 13.8 billion years ago, now just a faint glow at 2.7 degrees above absolute zero. They also examined supernovae, the largest 3D map of galaxies in the universe, as well as data from particle accelerators, nuclear reactors, and more. You see, as neutrinos are abundant but extremely tiny and elusive, the authors needed every piece of knowledge available in order to calculate their mass. The researchers used this information to prepare a framework in which to mathematically model the mass of neutrinos, and then used over 500,000 computing hours on the Gray supercomputer in order to calculate the maximum possible mass of the lightest neutrino, finding it to be 0.086 electron volts. They also calculated that the three neutrino flavors together would have an upper bound of 0.26 electron volts. Understanding how neutrino mass can be estimated is important for future cosmology studies, such as those being undertaken by DESI and ELUCID. DESI, the dark energy spectroscopic instrument, will study the large-scale structure of the universe, as well as its dark energy and its dark matter constituents to a high degree of precision, while ELUCID is a new space telescope being developed for the European Space Agency. It'll map the geometry of the dark universe and the evolution of cosmic structures. I'm Stuart Gary. You're listening to SpaceTime. The red planet Mars is about to reach solar conjunction. That's the period in its orbit when it's directly behind the Sun as viewed from Earth. Solar conjunction occurs roughly every 26 months. The event means the flotilla of Earth spacecraft orbiting Mars and on its surface will be blocked by the Sun from direct communications with mission managers back on Earth. Also, hot ionized gas in the Sun's corona, which extends far into space, interferes with those signals that do get through by passing around the Sun's limb. During solar conjunction, this plasma can interfere with radio signals when engineers are trying to communicate with Mars spacecraft, corrupting the commands, resulting in unexpected behaviors by the probes. So to avoid these problems, NASA mission managers undertake what's called a command moratorium. They hold off sending any commands when Mars disappears far enough behind the Sun's corona that there's an increased risk of radio interference. This year's command moratorium runs from today, as of recording, August 28th, through to September the 7th. It means the daily chatter between NASA's network of deep space communications antennas on Earth and the spacecraft orbiting around the red planet and on its surface will be getting much quieter for the next few weeks. In fact, some missions have already stopped commanding their spacecraft in preparations for the moratorium. Although some instruments aboard spacecraft, especially cameras that generate large amounts of data, will be inactive, all of NASA's Mars spacecraft will continue their science missions. They'll just have much simpler to-do lists than they'd normally carry out. On the surface of Mars, the Curiosity rover will stop driving, while the InSight lander won't move its robotic arm. Above Mars, both the Odyssey orbiter and the Mars Reconnaissance orbiter will continue collecting data from both Curiosity and InSight for return to Earth. However, only Odyssey will attempt to relay that data to Earth before conjunction ends. Meanwhile, another Mars orbiter, MAVEN, will continue to collect its own science data, but again it won't be supporting any relay operations during the moratorium. All this, of course, means there'll be a temporary pause in the stream of raw data and images available from Mars missions. Mars probes operated by other organisations, such as the European Space Agency and the Indian Space Research Organisation, will also be experiencing command moratoriums during the conjunction. And of course, once the conjunction is over, spacecraft will beam the data they've collected back to NASA's Deep Space Network as soon as possible. Engineers will spend about a week downloading the information before normal spacecraft operations can resume. Glenn Nagel from NASA's Deep Space Communications Centre near Canberra says if the teams monitoring these missions determine that any of the collected science data is corrupted, they can usually have it retransmitted as soon as the moratorium ends.
So for the Deep Space Network, as Mars passes behind the Sun from our field of view, it really just means that we're doing less communication runs with the fleet of 8 vehicles, spacecraft, that are currently exploring the red planet. So there won't be any uplinking of commands to the spacecraft because of the chance of those command's being corrupted as they have to sort of pass and bend around the sun. But it does actually give us a good opportunity to actually take a little bit more time to do sometimes much needed maintenance for the antennas and the network because of just some decreased overall workload. But for most part, we're still doing our work receiving that data from those spacecraft, even though they're hidden by the sun.
And of course, Mars isn't the only place that you guys are communicating with. There are NASA projects all over the solar system right now. Juno, for example. New Horizons is out there.
Yeah, so we still have about another sort of 30 missions that we still need to support that represent not just NASA, but all the other space agencies around the world that have missions in deep space. So we can give in the schedule a little bit more time to those missions, which I'm sure many of them appreciate, getting past the traffic jam that generally is the red planet.
How long does Mars solar conjunction last?
So it lasts around 10 to 11 days at its worst. So between the 28th of August to the 7th of September this year is when Mars will be behind the sun from our field of view. And for our antennas, of course, while we've got to still maintain some receiving of some data from some of the orbiting spacecraft, we make sure that our antennas, for a certain point, a couple of days, are not pointed directly in sun direction because that can, with those dishes, concentrate, as we normally do, radio signals. This time we'll be concentrating the sun's energy. So we want to keep those antennas and the receivers cool. If we're pointing our antennas directly at the sun, then of course it concentrates the sun's energy like a solar collector, and that energy builds up a lot of heat, which then reflects back into the instruments, the receivers on the actual antenna itself. So we make sure we're only pointing just a few degrees from the sun. There'll be a period where we make sure we're not pointed directly at our star.
That's Glenn Nagel from NASA's Deep Space Communications Complex near Canberra. And this is SpaceTime. I'm Stuart Gary. ASA, the Australian Space Agency, has agreed to a formal partnership with the European Space Agency ESA. The deal will see both agencies collaborate on future missions and projects, including deep space communications, navigation, remote asset management, data analytics, and mission support. Australia already hosts ESA's new Norcia Deep Space Tracking Station near Perth, which is operated by the CSIRO, and it's about to begin construction on a third radio antenna. Canberra and Brussels are also working together on the Copernicus program's Sentinel Earth Observation Satellite Constellation through Geosciences Australia. Australia's involvement with European space endeavours goes back more than half a century, back to the 1960s, when ELDO, the European Launcher Development Organisation, flew missions out of the Woomera rocket range in outback South Australia. Then, when ELDO moved to French Guiana to establish the Kourou spaceport and merged with the European Space Research Organisation to form the European Space Agency ESA in 1975, Australia was asked to join the new agency, but the then Whitlam Labor government declined the offer. You're listening to SpaceTime. I'm Stuart Gary. Rocket Lab has carried out its 8th mission, successfully flying 4 satellites into orbit. The Electron rocket blasted off from the company's Mahia Peninsula Launch Complex on New Zealand's North Island shortly after midnight, after initially being delayed by strong ground winds.
All stations on mission coord. Range is green, auto sequence armed.
Copy that, RCO. Flight avionics is flight on mission.
Flight avionics. Please lock the auto sequence and confirm.
Auto sequence is locked.
All operators, we are go for auto sequence start at T-minus minutes.
Avionics flight on mission.
Flight avionics.
Please confirm all AV bats have been switched to internal power.
Vehicles on internal power. Stage 2 is pressed.
High flow engine purge running and deluge running.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Liftoff detected.
And we're off the pad for our 8th Electron launch. Soon we'll be approaching the point of the flight where the forces against the rocket are at their peak, otherwise known as max Q, or maximum aerodynamic pressure.
HV battery discharge nominal.
Vehicle is supersonic, approaching maximum dynamic pressure. Passed through max Q.
Brutus has entered flight mode.
There you have it. Electron has gone supersonic and has made its way through max Q.
Guidance is nominal, 50 seconds remaining.
AOS Chatham Station.
Stage 1 propulsion remains nominal. Stand by for MECO in approximately 30 seconds.
Soon the 9 Rutherford engines on Electron's first stage will shut off ahead of its separation from the rest of the rocket. Once Stage 1 and Stage 2 have separated, the final vacuum-optimized Rutherford engine on Electron's second stage will come to life and propel Electron the rest of the way to orbit.
Stage 1 MECO confirmed.
Stage separation successful.
Stage 2 ignition. Propulsion is nominal.
And there it is. Main engine cutoff has been confirmed, and Electron's first and second stages have successfully separated. For the payload to be deployed from the kick stage, first the protective fairing needs to open up and fall away. Things are looking good, and propulsion is nominal as we approach fairing separation.
Fairing jettisons succeeded.
The fairing is separated, clearing the way for payload deployment.
Guidance is nominal. Altitude is 150 kilometers.
Mission control icon. Everything is looking great as Electron continues onto orbit.
Stage 2 HVB battery discharge is nominal.
Electron's Lookma
Stage 2
no-hands
propulsion
mission.
remains
We've had
nominal.
successful main engine cutoff, stage separation, and stage 2 ignition. Electron is looking healthy with a velocity of 10,000 kilometers per hour and an altitude of 220 kilometers.
Guidance is nominal.
Quick update from Rocket Lab Mission Control. Electron's propulsion is nominal ahead of our battery hot swap. Electron's batteries power electric pumps on the Rutherford engines, but once we get to this point in the mission, these batteries are depleted and we no longer need them. So we do a quick hot swap from the depleted batteries over to another fully charged one to maintain power to the engine and provide a much more efficient ride the rest of the way to orbit.
Throttling down.
Hot swap successful.
Battery jettison confirmed.
Stage 2 propulsion still nominal.
As you've just heard, we've had successful battery hot swap. So we're approximately 1 minute and 45 seconds away from kick stage separation. Velocity is 18,000 kilometers per hour and altitude is 304 kilometers. The Lookma no-hands mission continues to look good.
HV battery discharge holding nominal.
1 minute remaining. Speed is 6 kilometers per second. Altitude is 310 kilometers.
Just a quick update for you here on Rocket Lab's Lookma no-hands mission. We're about 1 minute away from kick stage separation and Electron continues nominally.
Entering burnout detect mode.
Guidance is in terminal.
Engine shutdown.
Good transfer orbit achieved.
The mission's primary payload was Bro-1, the first satellite of a new maritime surveillance constellation being developed by a company called Unseen Labs. Also along for the journey as part of a rideshare agreement were 3 smaller satellite payloads, including the Black Sky Global 4 satellite and 2 US Air Force technology demonstrators. All 4 payloads were successfully deployed into a 540-kilometer high orbit by Electron's kickstage 54 minutes after launch. The mission was Rocket Lab's 4th flight this year, taking the total number of satellites deployed by the company to 39. As with Electron's last launch in June, this flight also carried additional instrumentation on Electron's core stage, which will provide mission managers with data to help them develop a reusable version of the Electron first stage. Work on Rocket Lab's Electron first stage reuse program began last year. The project will initially see Rocket Labs attempt to recover an Electron first stage that's parachuted into the ocean after launch. They'll then refurbish it for reuse on another mission. That should happen within a year. Later, the company wants to begin capturing their spent Electron core stages mid-air using helicopters. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. The Amazon rainforest, which supplies a quarter of the planet's oxygen, is burning in what's being described as a global environmental disaster. So far, nearly 73,000 fires have been reported throughout the Amazon basin this year, a record number that's caused international concern for the future of the world's largest and most biodiverse tract of rainforest. The fires have been mostly set by loggers and by ranchers to clear land for cattle. Often called the lungs of the earth, the Amazon rainforest covers much of northwestern Brazil and parts of Colombia, Peru, and other equatorial South American nations. Despite the growing international concern, new satellite images have spotted over 9,500 new fires over the past week alone, further adding to the growing global disaster. A new study has found that humans are consuming significant amounts of microplastics, whether they want to or not. The findings are contained in the World Health Organization's latest report on microplastics in drinking water, which includes an early assessment of potential risks to human health. The study found that the average American now consumes more than 70,000 particles of microplastics a year. And people who drink only bottled water could be consuming an additional 90,000 microplastic particles per year, mostly from microplastics leaching into the water from the plastic bottles. The report warns that the direct effects on the human body of consuming microplastics are not yet well understood. While larger particles may well pass straight through, smaller particles could potentially be absorbed into organs. The report also warns that microplastics have the potential to both carry disease-causing bacteria and to help bacteria become resistant to antibiotics. It recommends drinking water suppliers and regulators prioritize removing disease-carrying bacteria and harmful chemicals from the water supply, as that would also remove microplastics from drinking water. However, the report says that ultimately the best solution would be to simply stop polluting the planet with plastics. Scientists have created the first ring-shaped molecule of pure carbon comprising a circle of 18 atoms. A report in the journal Science claims the chemists started with a triangular molecule of carbon and oxygen, which was then manipulated using electric currents to create the carbon-18 ring. Initial studies looking at the properties of the new molecule, called a cyclocarbon, suggest it could be a good semiconductor, making similar straight carbon chains useful as molecular electronic components. A banana-killing fungus, which has been decimating crops in Asia, Australia and Africa for decades, has now spread to the Americas, which produces the majority of the world's banana exports. A report in the journal Nature claims the fungus, known as Fusarium wilt tropical race 4, has now been detected in Colombia. It infects several varieties of banana and plantain, but is especially harmful to the Cavendish cultivar, which is by far the most common variety sold worldwide. In fact, practically every banana consumed in the Western world today, including those consumed in Australia and America, are a clone directly descended from the Cavendish cultivar, first grown in a Derbyshire hothouse 180 years ago from plants imported from Mauritius. It replaced the Gros Michel as the most exported and therefore most important banana in the world in the 1950s, when the larger, tastier Gros Michel was apparently wiped out by the Panama disease fungus. The Fusarium wilt tropical race 4 strain, which developed from the original Panama disease fungus, began destroying Cavendish crops in Asia in the 1990s, infecting banana plants through the roots and vascular system, starving the plant of water and nutrients. A new study has concluded that British food isn't all that terrible after all. A global survey has found that when it comes to having the healthiest packaged foods and drinks, it seems the UK tops the charts, with the USA in second place and Australia in third. The George Institute for Global Health analysed more than 400,000 food and drink products from 12 countries and territories around the world, focusing on the levels of sugar, saturated fat, salt and calories in many of our favourite food items. Countries were then ranked using Australia's Health Star rating system, which measures the levels of nutrients such as energy, sugar, salt, saturated fat, as well as protein, calcium and fibre, and then assigns a star rating from half a star, which is the least healthy, up to 5 stars, which is the most healthy for you. It found that the UK had the highest average Health Star rating of 2.83, followed closely by the US on 2.82, and Australia only just behind on 2.81. India had the lowest rating at 2.27, with China only slightly better at 2.43, and Chile coming in third from the bottom at 2.44. The findings, reported in the journal Obesity Reviews, shows that while everyone is consuming increased levels of processed foods, poorer nations are the least able to address the adverse health consequences from such a diet. Samsung has finally released its long-awaited Galaxy Note 10, and as expected, it's no longer just a single phone. Instead, you'll be able to choose from a regular Galaxy Note 10 or an even larger Galaxy Note 10 Plus. And for those of you living on the bleeding edge, there's also a 5G variant. With the details, we're joined by Alex Worosh from whistleout.com.
There's a smaller Note 10, which is 6.3 inches, and a larger Galaxy Note 10 Plus, which is 6.8 inches. And quite a big phone. Both still have the S Pen the Note series is known for, and there's a couple of interesting new features around that. You can now translate your handwriting into text directly. It even does pretty well with my garbage handwriting. Like, it's literally chicken scratch, and it still does an okay job of actually converting it into text notes. The smaller Galaxy Note 10 has a lower resolution screen, and it doesn't have a time-of-flight camera, which is used for depth sensing and photography, and this can create more realistic portrait shots. The larger Note 10 also has a larger battery and faster charging, but you need to get the faster charger as a separate accessory.
And the larger one's also got a 12GB RAM as opposed to an 8GB RAM on the Note 10.
Oh yeah, that's correct. But in terms of day-to-day usage, that's not going to really make too much of a difference. The Note 10 starts at $1,500, the Note 10 Plus starts at $1,700, and there's also a 5G version of the Note 10 Plus for those that are interested that starts at $2,000.
$2,000 for a 5G phone. Yeah, well, I guess we're going to be heading there, but that pen you were talking about earlier, you can use it pretty well as a remote control these days.
Oh, yeah, that's correct. So you can use it to remotely trigger the camera, you can use it to change track on your playlist, you can use it to flip through presentation slides without actually, touching the Note 10 screen. It's almost kind of like a magic wand. It's pretty cute functionality, and it's a little bit limited right now, but Samsung says it's making an SDK available to developers so that they can incorporate this kind of functionality into their own apps. But I guess it kind of remains to be seen as to how many will do that, given that the Note is a bit more of a niche product compared to Samsung's mainline Galaxy S series.
That's Alex Worosh from whistleout.com. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. SpaceTime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more SpaceTime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at SpaceTime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.